Hi, my name is Jonathan Miller Kauffman, and today I'll be talking about performance testing, a non-functional testing technique that is used to evaluate the performance of a system according to several metrics and under varying load conditions. There are many tools that can be used for performance testing, a few of which I've listed here. You should be doing performance testing because if you don't, you could release a system that does not meet end user needs. You could produce a site that on its go-live date only handles 6 users, or a medical device that ends up killing your patients. Both of these end up costing the business money. In order to evaluate the performance of a system, you should measure things such as speed, response time, throughput, stability, and resource usage. In addition to this, you want to ensure that the application continues to maintain correct functional behavior. All of this should be done under varying load conditions. These load conditions correspond to the 6 types of performance testing that I'll discuss in this presentation. I'll explain how each of these techniques work and why they are valuable. I'll then conclude by explaining how developers, DevOps, testers, and DevOps engineers can participate in performance testing. Load testing is a technique that puts ordinary demand on the application and then gradually increases that load over time until a peak load is reached. The application should continue to respond as expected during this time. This is probably the best known type of performance testing. Load testing is valuable because it lets you know whether your system can handle its expected usage. This technique is not limited to measuring the effect of adding users, however. You can also measure the effect of processing large files, performing intense calculations, or poor network connectivity. Stress testing is used to determine whether the system can handle usage above that which is specified in the requirements. It is often used to determine whether the system, with its current software and hardware configuration, can scale. The goal of this technique is to find the breaking point of the system. Stress testing is valuable because it lets you know how the system responds to load that it cannot handle. When the system fails during a stress test, you can determine whether memories persisted to disk, whether a log file contained useful content, and whether any security vulnerabilities are opened. Endurance testing, also known as SOAP or capacity testing, is a type of load testing that checks whether the system continues to respond as expected when used for long periods of time. This length of time depends on the system and could be hours, days, or even months. Endurance testing is useful for detecting issues like memory leaks that could be present in the application, the database, or in third-party software. This type of testing is especially important for testing things such as medical devices, which need to operate correctly when used for extremely long periods of time. In volume testing, also known as flood testing, an extremely large amount of data is fed into the system. This typically means loading a large amount of data into the database and then using the application to make sure that it behaves as expected. This is best described as shooting papers at a server. Volume testing is used to determine whether data loss, changes in response time, and problems with incorrectly persisting or overwriting data occur in response to large data volumes. It is used to determine whether the system can handle both current and future data volumes. In scalability testing, a set of load tests are run over varying software and hardware configurations to determine whether the system will scale. It differs from stress testing because it involves changing these configurations instead of trying to find the limit of the current configurations. Scalability testing is used to answer 2 questions. First, in what ways does changing the software and hardware configurations of the server affect its performance? And second, if the software or hardware are upgraded, will the performance of the system improve? And if it doesn't improve, why doesn't it improve? In spike testing, a large amount of load is unexpectedly added to or removed from the system. In either case, you want to determine whether performance deteriorates, whether the system starts to behave incorrectly, or if it is instead able to adapt to the sudden change in load. Spike testing can determine whether everyone in an organization will be able to log into an application at the same time after an outage. It can also be used to determine whether a system that is designed to automatically scale up to handle increased load automatically scales back down after load returns to normal. So how can everyone participate in performance testing? Developers should code with performance in mind and should use profiling tools in modern IDEs in order to identify and optimize frequently executed and expensive sections of code. Testers should be able to design, write, and execute all of the previously described types of performance tests. When they're deciding which of the performance tests to automate, they should focus their efforts on those that will be run as part of the DevOps pipeline. And last but not least, DevOps engineers can participate by incorporating performance tests into the pipeline. They should ensure that just enough performance testing is performed at each stage and should execute expensive performance tests out of band in order to improve pipeline performance. And so this concludes my presentation. I hope that I convinced you that performance testing is an important and complex part of a comprehensive testing strategy. Hopefully you'll consider performance the next time you are developing, testing, or DevOpsing. Thank you for your time.